When installing a triple meter base with three 100 amp service panels for a triplex, sizing the entrance cable appropriately is crucial. If the intent is to provide a 300 amp service overall, the entrance cable should be rated for at least 300 amps to handle the combined load of all three units. Using copper conductors can help minimize the cable size due to copper's higher ampacity compared to aluminum for the same gauge. A configuration using four 250 kc mil copper cables, one for each phase, and one for the neutral conductor, would provide a total of 1000 kc mil. This provides ample capacity for a 300 amp service, exceeding the minimum requirement and providing a safety margin for potential future load increases. While the electric company representative suggested that a 300 amps entrance might not be strictly necessary, and further said that 200 amp service is not big enough, it's important to conduct a load calculation to determine the actual demand. A 200 amp service could potentially be sufficient for a triplex, depending on the anticipated electrical usage of each unit. However, it is generally preferable to have excess capacity rather than operating close to the maximum limit, which can lead to overheating and other issues. If facing difficulties obtaining clear guidance from the electric company, engaging a licensed electrician is advisable. A qualified electrician can perform a thorough load calculation, taking into account the square footage of each unit, the types and quantities of appliances, heating and cooling systems, and other electrical loads. Based on this calculation, they can recommend the appropriate service size and entrance cable size to ensure compliance with the National Electrical Code, or NEC, and local electrical codes. The electrician can also handle the permitting process and coordinate with the electric company to ensure a smooth and safe installation. Consider that the NEC provides tables and guidelines for conductor ampacity, which is the maximum current a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. NEC Table 310.15b16, for example, provides ampacity ratings for various conductor types and sizes based on installation temperature rating and installation conditions. When selecting conductors, it's essential to consider factors such as ambient temperature, number of conductors in a raceway or cable, and termination temperature ratings of equipment. These factors may require adjusting the conductor ampacity to prevent overheating. Regarding the installation of the service entrance cable, ensure that it is installed in accordance with NEC Article 230, which covers service entrances. This includes requirements for clearances from ground, mechanical protection, and proper grounding and bonding. Grounding and bonding are critical for safety, as they provide a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers and fuses. The grounding electrode system should consist of a grounding electrode conductor connected to a grounding electrode, such as a ground rod, ground plate, or underground metallic water pipe. The grounding electrode system should be installed in accordance with NEC Article 250. Bonding involves connecting all non-current carrying metal parts of the electrical system together to create an electrically continuous path. This helps to minimize voltage differences between metal parts and reduces the risk of electric shock. Bonding should be performed in accordance with NEC Article 250. In the context of a triplex, each unit should have its own service disconnect, which is a switch or circuit breaker that can be used to disconnect the entire unit from the electrical system. The service disconnect should be located in a readily accessible location and should be clearly labeled. The overcurrent protection for each unit should be sized appropriately based on the load calculation and the ampacity of the conductors. Circuit breakers and fuses are designed to protect conductors and equipment from overloads and short circuits. Overloads occur when the current in a circuit exceeds the ampacity of the conductors, while short circuits occur when there is a low impedance path between two conductors. Overcurrent protective devices should be selected and installed in accordance with NEC Article 240. When installing the triple meter base, ensure that it is properly grounded and bonded. The meter base should be connected to the grounding electrode system, and all metal parts of the meter base should be bonded together. This helps to prevent voltage differences between the meter base and other metal parts of the electrical system. Also, ensure that the meter base is installed in a location that is readily accessible to the utility company for meter reading and maintenance. The location should also be protected from physical damage and environmental conditions. Consider the use of appropriate conduit and fittings to protect the service entrance cable from physical damage. Conduit should be sized appropriately based on the number and size of conductors being installed. Fittings should be listed for use with the type of conduit being used. In addition, be aware of local codes and regulations that may differ from the NEC. Local codes may have additional requirements for service entrances, grounding and bonding, and other aspects of the electrical system. It's important to consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. When selecting electrical equipment, such as service panels, circuit breakers, and conductors, ensure that it is listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. Listing indicates that the equipment has been tested and found to comply with applicable safety standards. Finally, document all aspects of the electrical installation, including the load calculation, service size, conductor sizes, grounding and bonding details, and overcurrent protection. This documentation will be helpful for future maintenance and troubleshooting and may be required by the local electrical inspector. By following these guidelines and consulting with qualified professionals, you can ensure that the electrical system for your triplex is safe, reliable, and code compliant. Remember that electricity can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from electrical shock and fire hazards. If you are not comfortable working with electricity, it's best to hire a licensed electrician to perform the work. The selection of 250 kc mil copper conductors is based on typical ampacity ratings and installation conditions. The NEC provides specific ampacity tables, and it is crucial to consult these tables for the actual ampacity rating based on the insulation type, temperature rating, and installation method. For example, THHN or THWN-2 conductors are commonly used for service entrance applications and have specific ampacity ratings depending on the size and installation method. If the conductors are installed in a raceway with other conductors, dirting factors may need to be applied to the ampacity rating. Dirting factors are based on the number of current carrying conductors in the raceway and the ambient temperature. The NEC provides tables and guidelines for dirting conductors. When calculating the load for each unit in the triplex, consider all potential loads, including lighting, appliances, heating and cooling equipment, and receptacles. The NEC provides methods for calculating both the general lighting load and the appliance load. The general lighting load is based on the square footage of the unit, while the appliance load is based on the number and type of appliances. For heating and cooling equipment, the load calculation should be based on the nameplate rating of the equipment. The nameplate rating provides the voltage, current, and power consumption of the equipment. When selecting overcurrent protection for each unit, ensure that the circuit breakers or fuses are sized appropriately to protect the conductors. The overcurrent protection should not exceed the ampacity of the conductors. The NEC provides guidelines for selecting overcurrent protection based on the conductor size and type. Also, consider the interrupting rating of the circuit breakers. The interrupting rating is the maximum fault current that the circuit breaker can safely interrupt. The interrupting rating should be high enough to handle the potential fault current at the service entrance. If the potential fault current is higher than the interrupting rating of the circuit breaker may fail to interrupt the fault current, which could result in damage to equipment and potential fire hazards. When installing the grounding electrode system, ensure that it is properly installed and connected to the service entrance equipment. The grounding electrode system should be installed in accordance with NEC Article 250. The grounding electrode conductor should be sized appropriately based on the size of the service entrance conductors. The NEC provides guidelines for sizing the grounding electrode conductor. Also, ensure that the grounding electrode is properly installed in the ground. The grounding electrode should be buried deep enough to be in contact with the earth below the frost line. This helps to ensure that the grounding electrode is effective even in cold weather. When bonding the metal parts of the electrical system, ensure that all connections are made with approved bonding connectors. Bonding connectors should be listed for use with the type of metal being bonded. The bonding connections should be tight and secure to ensure a low impedance path for fault current. Also, ensure that all metal enclosures, such as service panels and junction boxes, are properly bonded to the grounding electrode system. This helps to prevent voltage differences between the enclosures and other metal parts of the electrical system. When installing conduit, ensure that it is properly supported and secured. Conduit should be supported at intervals specified by the NEC. The support should be strong enough to support the weight of the conduit and conductors. Also, ensure that the conduit is properly sealed to prevent moisture from entering the conduit. Moisture can damage the conductors and equipment inside the conduit. When selecting fittings, ensure that they are listed for use with the type of conduit being used. Fittings should be installed in accordance with the manufacturer's instructions. Also, ensure that the fittings are tight and secure to prevent moisture from entering the conduit. Remember that electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from electrical shock and fire hazards. If you are not comfortable working with electricity, it's best to hire a licensed electrician to perform the work. Always de-energize circuits before working on them and use appropriate personal protective equipment such as insulated gloves and safety glasses. Double check all connections to ensure that they are tight and secure. And if you have any questions or concerns, don't hesitate to consult with a qualified electrician. The local utility company may also have specific requirements for service entrances. It's important to check with the utility company to ensure that the service entrance meets their requirements. The utility company may require a specific type of meter base, a specific location for the service entrance, or other specific requirements. Failure to comply with the utility company's requirements could result in delays or rejection of the service entrance. In addition to the NEC and local codes, there may be other applicable standards and regulations that apply to the electrical installation. For example, the Americans with Disabilities Act, or ADA, may require specific accessibility features for the electrical system. It's important to be aware of all applicable standards and regulations and to ensure that the electrical installation complies with these requirements. When preparing for the electrical installation, it's helpful to create a detailed plan that outlines all aspects of the work. The plan should include a load calculation, a wiring diagram, a list of materials, and a schedule of work. The plan should be reviewed by a qualified electrician to ensure that it is accurate and complete. Before starting any electrical work, it's important to obtain all necessary permits. Permits are required by most local jurisdictions for electrical work. The permit application should include a detailed description of the work to be performed and a copy of the wiring diagram. The permit must be posted at the job site during the work. After the electrical work is completed, it must be inspected by the local electrical inspector. The inspector will verify that the work was performed in accordance with the NEC and local codes. If the work passes inspection, the inspector will issue a certificate of occupancy. This certificate indicates that the electrical system is safe and code compliant. Throughout the electrical installation process, it's important to maintain a clean and organized work area. A clean and organized work area helps to prevent accidents and makes it easier to find tools and materials. Also, it's important to dispose of all waste materials properly. Electrical waste materials, such as wire scraps and conduit remnants, should be recycled whenever possible. By following these guidelines, you can ensure that the electrical installation for your triplex is safe, reliable, and code compliant. Remember to prioritize safety and consult with qualified professionals whenever necessary.